Welcome to my little introduction to Mégra, which is my domain-specific language that I made for live coding. And the workshop is titled Non-Deterministic Live Coding with Mégra, which is, I'm going to explain that first, I guess, because most live coding languages have some way to add some non-determinism. Title, for example, has the sometimes and often functions, or just plain random, which is always worth a chupito. And Mégra kind of embraces that idea that things are non-deterministic, and it sprung out from the idea that it's kind of boring if music always sounds the same if you hit play, so I wanted to sound my code a little bit different every time I execute it. And that's where the non-deterministic part comes from. And the underlying data structure, or the basic idea, is the whole language is based on probabilistic finite automata, which I'm going to explain later. Years ago, I had the idea that music could be notated as a graph. Probably not the first one to have this idea, but I wrote this little piece for an ensemble I was playing in. Played it once or twice for 13 minutes, and it was actually not super interesting, but it was fun, so I thought how to transfer this to the computer, and you will see later on that there's some very similar patterns in Mégra. I'm going to put the accent here. So, what are probabilistic finite automata, which are basically a very similar thing, or a representation of Markov chains? It's basically about conditional probabilities. So, the next event, in this case musical event, or the probability of a certain event to happen, depends on the previous one. And this can be made into music, into sound. It's kind of similar to, in some way, to the perception of music in general, because what we expect to happen next in a piece of music is basically dependent on the previous few events. And, it's just trying how to put that into code. And just to give you a little example to start, how does a PFA look like? I recently wrote a little visualizer for Mégra, which you can see on the left side. It might be interesting to see what is going on there. So, the most trivial PFA. By the way, I'm not going to cover any topics like installation of Mégra or installing Common Lisp, all this kind of things. If you're interested in that, I'm happy to answer all questions or to give tutorials out. There's a tutorial, there's documentation, which is slowly growing on the GitHub page that you should be able to see on the top left on the screen. And contact me on the Top Lab chat, on Telegram, anywhere else, and I'm happy to help install it if you run into problems, which is not unlikely because it's not the easiest thing to install. So let's see. So very trivial PFA, probabilistic finite automata, would look like this. Let's put a sawtooth wave here, 130 Hertz. The basic syntax is this is basically an event sync, or it's a bit similar to the D1, D2, D3 things on in title, or there's something similar in Foxtrot. I forgot how it's named. It's basically where all the music events go to be turned into actual sound by Super Collider, which is running in the background. And give it a little duration, 500 milliseconds. Let's see what happens. So you can see it on the left side. It's just one event that is followed by itself all the time, which is a little bit boring. So let's see how we can turn it into something more interesting. This is the equivalent to hush in title, by the way. Clear all the sessions. And one of the nice things about PFAs is that they can be created in many different ways, like the way we saw here. It's just a nucleus, one event that is, I called it nucleus because it kind of makes sense. That's just followed by itself, and the manual way to create PFAs is basically that you can specify them by a bunch of rules or infer them from rules. The respective function in Mégra is called infer. Pretty simple. So first you have to define an event key, of course. Let's say you define X as a snare drum and O as a bass drum. And maybe we can define, I don't know, H as hi-hats. So now we've got all the ingredients to create a beat. Now we need some rules. What follows what? This can be done here. So let's say, well, after a bass drum follows a snare drum with a probability of 100%. That is always. And let's say after a snare drum follows the next bass drum with a 50% chance, or the hi-hats also with a 50% chance, and after every hi-hat follows the bass drum again. Let's see how that turns out. If there's no syntax errors in there. There seems to be a syntax error. What did I do wrong here? Something seemed to have happened. So I've done something wrong here. For a simple way.
Your hat's only 50%.
Huh? Oh, no, it's not. Give it a different name. Something crash? I don't know. Well, off to a good start, I guess. Let's see if the other stuff works again. I probably encountered countless bugs during this workshop because that's just how things go. Oh, I got my error. It's not called. The event key is called events and not event. That was an easy one. No? Still not? What am I doing wrong here? Okay, at least this one still works, so I know that nothing has crashed. Oh, well, yeah, of course. Just did my event key wrong here. This is a little bit more explicit, I guess. And obviously, I confused those. Let's see. There we go. And let's make it a little bit slower so you can see what's going on. visualizer on the left, that's where things are happening, and you can see that it seems to be a little bit out of sync. I just finished this one yesterday, so it might not be the most precise thing. Seems to be one beat behind now that I see. Okay, let's make it faster again so that doesn't. So, yeah, apart from all the confusions about the event keys here, that's how you can specify rules by hand, and of course that's a little bit tedious. So, over the time I created some shortcuts that allow to create some descriptions that are more that are closer to the way we commonly think about music. For example, the single event that gets always repeated. Explained that already, and I added a little pattern syntax, as it is quite popular amongst creators of domain-specific languages. And so the same thing, or not quite the same thing, but if you want to define a simple beat, I guess I'm going to stick with beats as examples. Just as a loop, it'd be way shorter to just do that using this abbreviation. And now the visualizer is also in sync, which is very nice. So yeah, just to create a simple beat loop, you can create a PFA, which in this case is of course completely deterministic, from an abstraction, that an abstract description of a loop, or some people might say a pattern, but I prefer to call it a loop. And if you want to add some non-determinism to it, you could, for example, add a certain chance of events to be repeated. Now we're getting into more interesting territory. Let's say we add a 70% chance for every event that it will be repeated, but never more than 3 times. And now you can see the repetitions here. I'll move them to the middle a little bit. So as you can see here, still have our basic loop, but now the repetitions are added, and after every repetition it will be evaluated if we should move on to the next event or not. This is basically a very abbreviated description. Normally there would be some intermediate events that are left out because it make this thing a little bit confusing. Another way to add some non-determinism to the whole thing is to add random connections between the different nodes. For example, go back to the basic loop, but now between every 2 nodes, between every 2 events, there's a random chance of a shortcut, or like a random edge is added with, let's say, a chance of 70%. So now this whole thing sounds a little bit random, obviously, because there's a lot of random connections in here. So at some point it might get out of hand, and the whole idea about it is to keep the balance between randomness and non-determinism, but still make it enjoyable. And well, completely random noise is not always that much fun to listen to. It gets boring easily. So at some point it's not too bad to go back to a more deterministic state, and that can be done quite easily. And another cool thing about PFAs is that they cannot only be created by rules, as we saw in the first example, or by an abstract description, as we saw in the second example, but they can also be learned from data learned in the machine learning sense. And I think that's a very cool feature, because you can theoretically you could use any data to create interesting sound structures. In this case, it's usually just imagination, and let's see how I'll end up. So the respective function is confirmed. Just as a side note, why does it have all these quoted little symbols here? Pretty much everything is named in Mégra. You have like this event sync is named Ga, the cycle is named 2, and there's a reason that I will explain in a little bit, and it's necessary, so you have to come up with names all the time, which sometimes is a little bit annoying, but you'll get used to it. So let's learn a generator called toe, why not? And again, we have to define a key for the events that we want to use. Say a bass drum here, and a snare drum there, and those are, by the way, limited to single character symbols, as we'll see later. Little Casio blip. If you want to try out some sounds, there's the once function that's helpful if you just want to try something. Mégra is mostly sample based, by the way, so there's a folder on my hard disk that's called Casio, and that has all the Casio samples from a Casio keyboard. And if you don't specify any keywords, it will choose a random sample from that folder. And if you specify a keyword like high, it will always choose a sound that contains that keyword in the file name. This is low, and there's the Casio noise. That's only 3 samples that are in this folder. And I think I'm going to go with the high. And of course we'll need some data to learn from, and this can be specified as such. You just type random data here, or data that seems to make sense to you. The tilde, by the way, is always the silence. That doesn't have to be specified explicitly, because I use that all the time, and it's pretty well known in the community, from Tidal, from other languages, that the tilde is somewhere used for silence, so I just went with that. So you can specify some data and try to learn the distribution from that. Let's see. And well, now it's up to you to see if most of the time bass drum follows a snare. So, well, you can hear that. The visual representation, of course, is a little bit chaotic, as you can see. You have to pull that apart a little bit to see what's actually going on here. But let's change it a little bit. Does it match? Do you think? I don't know. To me, it matches. Like, always inserted the Casio sound in between the bass drum and the snare. And yeah, you can hear the difference. If I always at the silence. data sample gets. The more complex the generator gets, as you can see here. At some point it's not really, it's more like visuals than actually helpful. I'm going to check occasionally on Telegram if anybody has a question, because I'm not seeing the YouTube stream here. Let's see. No. If there's any question, just, I don't know. I hope somebody will forward them to Telegram, because I'm not seeing the YouTube stream or the comments there. Or just write them down and ask me afterwards on TopLab chat or the Algorithmic Barcelona channel on Telegram, or privately. I'm open to that. Per email. Okay, so like we have now encountered 3 methods to create PFAs, or very basic PFAs. And the last method that also shows a little bit what you can do with PFAs is just start out with a very minimalistic starting point and create them step by step. So to go back to the initial nucleus, one of my favorite sounds, short triangle burst. Hey. There's a function called grow in Mégra, and that basically allows you to insert new events, new occurrences with copied from the old events, or from varying the material by inserting new events. For example, it's a certain variation factor. That didn't work. There's a bug here, by the way. It shouldn't be like that. Changed it yesterday, obviously now it doesn't work. Let's try that now. So you can see after 10 steps, every 10 steps, this is a little time-based modifier, a new event is inserted into the generator. So it grows over time. You can start with a very small starting point and go from there. And that way create your generator step by step. And you don't have to do much. Basically it works on its own, which is kind of cool, because you might get surprising results that you didn't expect, and to me that's always a lot of fun to see where things develop. If you add them, for example, with a very high variation factor, you might get a more chaotic generator. As you can see with the pitches, they're significantly more different than they were before. It's a little bit less. Visualizer is sometimes a bit slow. And so on and so on. So it grows step by step. And you can base some techniques around that and make more complex operations on those PFAs, because the nice thing is they're kind of human readable. I mean, of course, once they get to a certain level of complexity, you need to dig a bit to find out what's going on. But if you compare that to other structures like neural networks, where it's just edge weights, and if you change something, it doesn't really have a meaning on its own, but here it kind of does. You can still see, okay, after this event called so-and-so follows this event always, or you can even write programs to analyze them and define meaningful operations on the generator. So you have a lot of ways to interact with that model. So to have a little bit more complex operation, to show you a little bit more complex operation, there's an algorithm or function called live, which is a very primitive idea about like a very primitive life modeling algorithm. So imagine there's a certain amount of resources available, which are a little bit implicit, but I can set them, say, to 300. And as we saw, like the generators grow and grow and grow, but to limit that growth a little bit, can tie it to the resources. So every time the generator grows, it takes a certain amount of resources, and once the resources run out, it reaches a certain stable state. So you can define a growth cycle. Let's say every 5 steps a cell is added. Every cell has a lifetime, so there's no life without the opposite. So they perish after 3 evaluations, and every time it's added with a factor of 0.5. Let's see where that goes. So as you can see, there's rarely 2 in parallel because they just disappear before new ones can appear. So let's enhance the lifespan a little bit. And now we can see this is frequently growing into more interesting generators. You can mix in durations to spice things up rhythmically a little bit. Let's see what I find now. Every time you... Oh wow, now it's getting way faster. And more interesting. So, every time a node is added, one of these durations will be chosen. Just to starve it a little bit, let's reduce the resources so it can't grow any further. Well, it still does. There's a description and documentation that I wrote recently, so if you want to see what's going on here in depth, you might want to read that. But just to show you, oh my god, this is getting out of hand here. As you can see now, it can't grow any further. The resources are used up and kind of reached a stable state. And should see nodes disappear at a time. At times. Which they tend to run out. But anyway, so that way the generators can be modified over time and create more interesting structures. and that's the basics of creating or music generators with Mégra. And now you can start combining them and playing around with them and applying all the nice techniques that are quite common in live coding. So the technique that is a little bit, I have to admit, is a little bit borrowed from Tidal, is juxtaposing two generators or a variation of the same generator, except that here it's not really patterns or loops or anything, it's just the generators have their own, a little bit of a life of their own, and might act in unpredictable ways, which, as I explained in the beginning, is the whole idea about Mégra, that becomes a little bit unpredictable. So the CMP function, by the way, is the compose function. As we're working in Lisp, normally you would have to, or you can express this thing like so. That would be the function call in Lisp. I don't know how familiar with S expressions you are. Usually this is the name arguments and so on, and it's always between parentheses. That's the most typical feature of Lisp, I guess, and always has a fixed evaluation order. It's not as confusing as some other languages. So, well, usually it would look like this, but the compose function allows us to take things apart a little bit and hey. There we go. Oops. Step here. So if you're happy with the generator, you can just comment out the live functions and leave it where it is and just let it run. You have to specify the reset flag. In the common Lisp world, true is just a T and false is nil or empty set or whatever you want to call it. It's just convention. By the way, if you don't want to clear everything, you can just use a nil here. This is just the flag whether this sync is active or not. Why does it appear visualizer right now? So we need to clear something. So what if we could, let's say, start with another example. Have a simple beat. This is a very intuitive way to explain it. There we go. A default beat. That's aggressive snare drum, bass drum, and if we could combine combine that with a copy of itself, that's variating a little. And that's what, for example, the xspread2 function is about. Creates copies of the generators, applies some modifications, and spreads them over the stereo spectrum. This is what the 2 is about. If it was 4 channel, it was 4, or for 8 channel, it was 8. And it's very similar to the jux function in title. So I can want maybe to have the pitch a little bit higher. So I multiply the rate with 1.2. Now it's still the same generator, just a little bit higher. But I'm not happy with that yet, and I want the copy to have random connections, so it generates a little bit of variation. So just add a random. And now it starts to get interesting. As you can see, here's the static original, and here's the variating copy of it. That sounds kind of nice. Okay, there was a question to explain the learning algorithm, and so this one. Well, I was not prepared for that, to be honest. Basically checks subsequences of variable length, and once the chance that like subsequence COC is followed by an X, as you can see, that happens 2 times directly in a row, so, or even 3 times. So once the chance passes a certain threshold, a rule is added to the generator, as we can see here. So it basically the algorithm analyzes the sample and adds the rules or infers the rules accordingly. And if there's no significant rule to be inferred, like maybe, then it's just not added. So it's not necessary to add all possible rules of, let's say, length 3, but I didn't explain that the rules cannot only have a single event source, but multiple events as well. So you could define rules that say, I don't know, let's give the hi-hat a certain chance to be repeated in this old example. Say 40%, so 40% chance of repetition. Well, let's go higher, let's go 80%, and the rest will go back to the bass drum as before. So now we could theoretically have infinite repetitions of the hi-hat. As you can see right now, it's repeated quite often, but that might not be what we desire, so we can define a new rule that the hi-hat is repeated, in this case 4 times at maximum. And now, as we can see, the repetition rules are reflected by the generator. It goes to state. So every state can have a variable length of the sequence that it models, and after option that's left is to go back to the bass drum. And the learning algorithm basically analyzes the sample sequence that you give it and infers all the relevant rules of a certain length, which is the difference to fixed length Markov chains. Like in fixed length Markov chains, you would have to specify all the rules for all possible combinations of 4 events, and that would be an exponential size, so that would not be viable or not be quick. But in depth, if you want to follow that in depth, I can send you the paper that describes the algorithm in depth, and that's way more productive than me mumbling here about things that I implemented a couple of months ago and in part already forgot because they work, and I have to refresh my own memory here. So much for that. So back to juxtaposition techniques in Mégra. Yes, that's where I was. So here was the random part, and I can add more probabilities that are just to make the sound a little bit more lively. So my favorite currently is it's just my own inside jokes that the always function is called pair, but I'm using the pair, probabilistic pair, chance of 30%. Add some dubby reverb effects and echo effects. And maybe even add another layer that adds a little bit more rhythmical variation. For example, every 30 steps, make the whole things a little bit faster and haste through the evaluation, speed of the evaluation for 4 steps, and make it twice as fast. And now it's getting more and more complex, and at some point we'll probably drown in the chaos. Let's maybe add some baseline that's learned from some examples. Super creative A minor chord. By the way, generators that are specified in the same SX environment are automatically synchronized, so you don't have to take care of that. apply the same technique to our baseline, for example. Add another layer. This time it's not the rate, because this is not a sample, by the way. There's certain events that are synthesizers, like this short triangle wave-based sound. And you have to check the documentation to see which is which. So synthesizers are modified by pitch multiplication, not by rate multiplication. Now you can add more and more layers. Let's add the act to octave. Apply the same techniques to those. That's a question on Telegram I just heard. Just going to answer that soon. Okay, Glenn had a question. Thanks for that. No, that's currently not. So the question is, I don't know if you can read that here. Can there be a higher level knowledge about the generators, for example? What is it? For example, can I define an overall cycle that it will be restarted every 8 beats? To get a more pattern-like structure, or probably something like defining more important events or like more central events. And this is not implemented right now. And to be honest, I was even kind of reluctant to even add something like a cycle generator, like a little pattern sub-language, because in the beginning, I was really focused on using non-cyclical time, like everything should be independent. This is why you can still define completely independent structures in Mégra. There's no, I mean, there is basically a current or like an overall meter, but in theory, you can define every durations are defined as milliseconds. It's basically real time. So, oh wait, sorry, I need to rename that, of course. Let's see, this is a little bit too complex to stand out. I have to reduce it a little bit. So as you can see, there's no, it's basically just because the default value of the durations is set to 200 milliseconds everywhere, that things are synchronized, but there's no common beat even, or common meter. That all just, so the basic idea, the original idea was to let everything emerge just from structures, but of course if you want to play an algorave, then having a certain rhythmical structure is kind of practical. So those pragmatic evaluations, or not evaluations, sorry, these pragmatic considerations took over at some point, and now it's pretty compact and you don't need to specify everything explicitly. I mean, the original Mégra was all about these rules and specifying them by hand, and I mean, you can specify durations in here too, like there's just the default duration of 400 in this case, but you could specify something very arithmetical, which was so now you not only specify the probability, but also the duration, which is like can be just about anything, and there is no obligatory beat or no beat imposed. But yeah, as I said, like over time, the pragmatic algorithm stuff took over, and that's where I ended up. To go a little bit further into that, you can even, as I showed before, define the life modeling function that I showed you before on one of the copies and have a and now it basically works on its own. You don't have to do much anymore. Just improvising without supervision, which is of course not 100% true. There's a lot of intervention by the performer, because otherwise why would I be on the stage as a performer if I don't have any influence on what I'm doing? Okay, so yeah. So it basically runs and runs and runs, and the static parts give it a nice stability, and the dynamic parts add the liveliness, so it doesn't get boring. And if I want to avoid moves and getting too static, I can reset the global resources, so all the generators have enough to eat. I think for every time it grows, just one is subtracted from that. That's a nice snare pattern. Another thing that I wanted to show after this is that it's kind of boring just to have two shapes, the cycle and the nucleus. So recently I found some ways to create some more interesting shapes. Just if you wonder what all the words mean in Mégra when you see me performing. So a nice shape to create a more interesting graph is the flower shape, which stay with simple A minor harmonics, just maybe add an F in here, and it's mostly A minor, because A minor is nice. I like A minor. So the flower function arranges the notes around a central node. So you will always come back to that node to the central node, and that gives it a certain stability. It's not super interesting on its own, but it's really nice if it's mixed up with a beat. Oh, that's a little bit too much maybe. It's cool, I like it. To go back to the original function. Can be layered, so if you want to have more than one layer, let's say 2 layers, or 3. No, 2 is nicer. So now you have a more complex structure to start with, and maybe you don't even need the live modeling algorithm because it's already complex enough as it is. 3 layers to have short sequences of 3 notes that get repeated, or 3 events that get repeated. Another nice shape is what is called a friendship graph, which is normally an undirected graph. This is where it's just called like that. I didn't make that up. It's just called like that in graph theory. So it gives the whole language a little positive vibe. Flowers, friendship, pears, apples. I like that. So this creates little loops of 3 events that always come back to the center. And each of these loops is chosen with the same probability. So it's a nice way to harness the randomness without going too deterministic. And again, if you add a beat to that, and maybe create a copy of that as well. start out with slightly more complex generators. And the last one, it's kind of esoteric, but well, what isn't in the world of live coding? If you want to have a completely random generator in Mégra, that can be done as well by creating what is a fully connected generator. To make this a little bit smaller, so there's at least some chance to see what's going on. So here it is basically a random sequence generator, because every event has the same chance to follow the next event, and so on and so on. Every event is connected to every other event. But that's a nice way to also modify it over time, for example. To apply what I call this encourage algorithm. So if you want to encourage this generator to keep doing what it's doing, you can specify, let's say, every 10 steps. It will follow the trace that the events left and amplify the probability, so it will start repeating itself after a while, because as you can see now, certain connections get stronger over time, and gets more regular, because what happened in the past will be more likely to happen again, because it follows the last 9 or so events and just creates stronger connections between those. And at some point you might just end up with a loop of 2 or 3 events. You really have to listen closely to the differences, but where there's an encouragement, there could be a discouragement as well. So I'm going to keep things in balance, and so now it's pretty static. Ended up in a loop state, so it's just looping 2 or 3 events all the time. And to break things up a little bit, we can apply the opposite. So it follows back the last 9 or so events and makes sure that this sequence becomes less likely, and that way makes the connections weaker between those elements. There's another question on Telegram. Thanks, Alicia, for oh, is there a way to export? Yeah, that's a good keyword. There is, but I never use it, so I forgot what it's called. But let me see. What was it called again? To code? No. I have to check the documentation, because I found that a good idea to learn something and then reuse it afterwards. But I never even once used that in my own practice. So I have to check myself. I wrote that down somewhere. By the way, here on the GitHub account, the Druncoder Mégra. You can access the documentation that's there, which I'm trying to improve step by step. Where is it? I thought I wrote a paragraph about that. Huh? I didn't. Strange. I'll find out and tell you afterwards. I really forgot. You can export as an SVG, but not necessarily. Wait, I'm going to check. That's it. It was to code, okay. So once you have a generator, learn, sample, and now there's to code. Now I have to specify this, for example, why everything is learned, because there's some way to modify stuff from the outside. To export it and other things. So now there should be a file in the root folder. And the thing is, it always exports the rules, so it's exporting not the exact same code, but the rules representation of the generator, as I explained to you before. So it's a little bit complicated to read that after the fact, but yeah, it's possible. You can just store them, and there's even a function to load it from that file directly. Let's see if I can find that. It's basically just Mégra, is that right? So now it loaded the file, and let's see if that works. Is it just no, that doesn't work anymore. No, I forgot. Sorry. I'll check and tell you later. Anyway, that was a basic introduction into Mégra. Now I'm going to go back and fix the bugs that I found during this workshop and work on the documentation. So I would be happy to receive questions if anybody can install it. I'm happy to help, especially if anybody would be willing to try on Windows, because I don't have any access to a Windows machine, so I have no idea if that is even possible. Theoretically it is, but I don't know because I never tried. Other than that, that's it for the moment. Thanks for watching, and goodbye. Stay safe. Enjoy the desconfinamiento, and next time, see you live and in person maybe. Bye.